Hi all, welcome to another one series of Chemflix. Here we are going to discuss this series is mainly for PGT chemistry, those who are preparing for PGT chemistry, for KVS, those who wish to join in KVS, NVS, or either they have to get some job in a higher secondary school teacher like that. So in the series, first we are going to discuss about the syllabus of PGT chemistry, and then we are going to discuss the syllabus based questions, MCQ questions, solving previously year questions. Okay, so mainly this is based on Neet JE chemistry. Most probably Neet based questions you can expect in PGT chemistry based. Okay, so we'll see about the syllabus. Okay, the dimension of pressure are the same as that of option force per unit volume, energy per unit volume, force, energy. So how to solve this question? You know the first chapter units and dimension, the question is from that. So here dimension of pressure are the same as that of force per unit. So first of all you have to know what is pressure. Pressure is equal to force per unit area. Okay, force per unit area. So what is this force? Force is equal to mass into acceleration. So you know that divided by area it is a square. Okay, so here a and a gets cancelled, m by a. So here m is capital M, area is, here this a and a will not get cancelled, sorry. Here a is for acceleration and this a is for area. Okay, this area is a is for area. So here m into a divided by area, you know, L. Okay, area is L square. So here m into a divided by L square. Acceleration, you know, acceleration is equal to velocity by time, and velocity is equal to speed into speed divided by time. So s divided by t into t. S speed is distance divided by t square. Distance you can measure it in L. So L by t square will be A. So here I'm going to substitute this in this equation. Capital M into L into t raised to minus 2. The t square can be represented as t raised to minus 2 divided by this L square. So this cell in this cell get cancels, and what you will get, m into L raised to minus 1 t raised to minus 2. So this is the dimension of pressure. So the dimension of pressure is m L raised to minus 1 t raised to minus 2. So you have to find out which of this option having the same dimension. So force per unit volume, force divided by unit volume, F by V. So here it is force by area and here it is force by volume. So this is wrong. Now energy per unit volume, energy per unit volume. So you know energy is equal to E is equal to mc square divided by volume is A cube. So here m into c square, you know, c is the speed of the light. So here you know that speed is equal to distance by time. Speed is equal to distance by time. So here distance is in L. Okay, length. Time is capital T. L t raised to minus 1, that is speed. So here c square. So L raised to 2 t raised to minus 2 divided by L cube. Now we are going to find out the dimension of energy per unit volume. So here this L square gets cancelled into this 3 and remaining 1. So m L raised to minus 1 t raised to minus 2. So obviously our answer is ml raised to minus 1 t raised to minus 2, ml raised to minus 1 t raised to minus 2. Answer is energy per unit volume. So the right answer is energy per unit volume. Okay. Now moving to the next question. Given the numbers 161 centimeter, 0.167 centimeter, 0.0161 centimeter. The number of significant figures for the three numbers is 3, 3 and 4 respectively, 3, 4 and 4 respectively, 3, 4 and 5 respectively, 3, 3 and 3 respectively. This is a previously asked question. So this is based on the significant figures. So you know that 161 centimeter, how many significant figures? 3 significant figure. 0.161 centimeter, you know that before the decimal point, left to the decimal point, the 0 we will not take. So this also possesses 3 significant figures. So obviously this option B and option C ruled out, remaining A and D. So depends upon the last one. 0.0161. So the zeros placed left to the number are never significant. Left to the are number are never significant. That means never significant. That means this zero is not significant. This zero is not significant. So here also, what is the significant figure? 3 significant figure. So the answer is option D, 3 comma 3 comma 3. Okay. So this is from area significant figure. Now move to the next question. Equal masses of hydrogen, oxygen and methane, equal masses, same mass, have been taken in a container of volume V, okay, at temperature 27 degrees Celsius in identical condition. So mass, equal mass they are taking, and in a container of volume V, same volume, mass, equal mass they are taken at 27 degrees Celsius. The ratio of the volume of gas would be ratio of volume of the gases you have to find out. So you know that Avogadro hypothesis, Avogadro hypothesis. So according to Avogadro's hypothesis, ratio of the volume of the gases is equal to the ratio of number of moles. Okay, equal to the number of moles. So here how you want to find out the volume? You have to find out the volume by number of moles. So how will you find out the number of moles? Number of moles is equal to mass in gram divided by gram molar mass. Okay, so you know the gram molar mass of H2, capital M. Molar mass of H2 is equal to okay, H2 is equal to 2. Molar mass of oxygen is equal to 32. Molar mass of methane is equal to CH4. 4 plus 12, 16. Okay. So what will be the ratio? W divided by capital M, that is W divided by 2 is to W divided by 32 is to W divided by 16. Or okay, how will you find out the ratio? You will get 16 is to 1 is to 2. Okay, what you are doing? Here you have to take, here this is the largest number 32. You have to 32 divided by 2, 16, 32 divided by 32, 1, 32 divided by 16, 2. So 16 is to 1 is to 2, that will be the ratio. Here 16 is to 1 is to 2, option C will be the answer. This is 2014 question. Now the next question, what volume of oxygen gas measured at 0 degrees Celsius and 1 atm is needed to burn completely 1 liter of propane gas C3H8 propane measured under the same condition. So from the question itself, you will get an idea that volume of oxygen gas measured at 0 degrees Celsius and 1 atm. You have to find out the oxygen gas. Burn completely. You are burning completely C3H8. You have to burn it completely. So C3H8 plus oxygen. Burning in presence of oxygen. Oxygen gives. What will you get? Okay, carbon dioxide you will get. Remaining water also you will get H2O. Now you have to balance this. C3H8. So here how many carbon atom? 3. So here I am going to add 3. So here if it is 3, 3O2, that is 6. So here according to here, and here how many H8? Here H8H, here 4. Okay, I have to add 4 here. So 4 oxygen plus 6. So what you will get here, 5 oxygen needed. Okay, now this equation is balanced. Now here 1 volume of C3H8 needed 5 volumes of oxygen atom to completely react to get 3 volumes of CO2 gas plus 4 volumes of H2O. Okay, is it clear, right? Okay, now here what volume of the oxygen gas is measured at 0 degrees Celsius and 1 atm is needed to burn completely 1 liter. So suppose if it is 1 liter propane gas, how many volume, how many liters you need? 5 liter of oxygen. Very simple question. This is previously asked question in 2008. Moving to the next question. 0.24 gram of volatile gas upon vaporization gives 45 ml vapor at NTP. What will be the vapor density of this substance? Density of H2 it is given 0.089 gram per liter. So here weight of the gas is given as, weight is equal to, weight of the gas is 0.24 gram. And the volume it is given as 45 ml, that is 45 into 10 to the power minus 3 liter. Okay, vapor density. So here density of hydrogen also given. Density of hydrogen is equal to 0.089 gram per liter. So weight of here 45, okay, so weight of 45 ml of H2 is equal to density into volume, that is equal to 0.089 into 45 into 10 to the power minus 3. 45 into 10 to the power minus 3, which is equal to 4.005 into 10 to the power minus 3 density into volume. So gram. We have to find out the vapor density. Next we have to find out the vapor density. Vapor density is equal to a weight of certain volume of substance. Certain volume of substance, that is 0.24 gram. So 0.24 divided by weight of the same volume of hydrogen. So weight of the same volume, that is 4.005 into 10 to the power minus 3 gram. So what will you get? 0.24 divided by 24 divided by 4. 6. So 59.93. 59.93 will be the answer. Moving to the next question. The molecular weight of oxygen and are 32 and 64 respectively. Okay, second. Okay, the molecular weight of O2 and SO2, it is SO2, are 32 and 64 respectively at 50 degrees Celsius and 150 mm Hg pressure. 1 liter of O2 contains N molecules. The number of molecules in 2 liters of SO2. So 1 liter of O2 contains N molecules. The number of molecules in 2 liters of SO2 under the same condition of temperature and pressure will be 2N, right? 2N. Given that the molecular weight of O2 is 32, you know that the molecular weight is 32. O2, the molecular weight is 32. And also the sulfur dioxide, sulfur is 32. 32 plus 32 will be 64. So that is given. So 1 mole, both are 1 mole. 1 mole is O2 and 1 mole SO2. So at 15 degrees Celsius and 150 ml, 1 mole contains N molecules. So 1 mole of oxygen contains N mole. Both are 1 molecule. So here 2 liters of SO2 contain how many molecules? 2N. Okay, same. Nothing to worry. 1990 question. What is the weight of oxygen required for the complete combustion of 2.8 kilogram of ethylene? What is the weight of oxygen required to complete combustion? Ethylene. Ethylene is actually C2H4. Complete combustion means addition of oxygen. To give what you will get a hydrocarbon when burning, you will get a CO2 and H2. You have to balance this reaction C2H4 plus CO2. Balance it 3 oxygen. C2. So here 2. 4 plus H4. So here also 2. So here what we will get? 3O2. 6, no? Okay, very good. Now here C2H4, calculate the mass. 28 gram of C2H4 react with 3O2, that is 96 gram to give 2 CO2 plus 2 H2. For complete combustion means here what is here? 2.8 kilogram. So complete combustion 2.8 kilogram of C2H4 requires requires 96 divided by 28 into 2.8 into 10 to the power 3 gram. So what will be the answer? 9.6 kilogram of O2 you needed. Where is the answer? C. Okay, option C. Moving to the next question. An element X has the following isotopic composition: 200X 90 degree. It's actually X 200. Okay, that is 90%. That X 199, that is 8%. It's a 90. X 202, what is that? 2%. The weighted average atomic mass of the naturally occurring element X is closest to. So you know that how to find out the average atomic mass, right? Average atomic mass is equal to average atomic mass is equal to, this is class 11, no, class 9. Average atomic mass is equal to 200 into 90 divided by 100 plus 199 into how many? 8%, right? 8 divided by 100 plus 202 into 2 divided by 100. What you will get? Ultimately, you will get a 199.96 AMU. That is equal to 200 AMU. Do you have this answer here? 200 AMU, right? Option D will be the answer. 200 AMU. Moving to the next question. Boron has two stable isotopes, that is boron 10 and boron 11. Calculate the average atomic weight of boron in the periodic table. Same way. Okay. So 10 into 19 by 100 plus 11 into 81 by 100. What you will get? 10.81. Option A. Now this is from another area, that is mole concept and molar masses. So based on that, the first question is, which one of the following has maximum number of atoms? 1 gram of silver, 1 gram of magnesium, 1 gram of oxygen, 1 gram of lithium. So this question was asked in Neet 2020. Okay. So here, which one of the following has the maximum number of atoms? You know that 1 mole of substance contain Avogadro number of atoms. Okay, Avogadro number of atoms. So 108 gram of Ag is equal to Avogadro number of atoms contain Avogadro number. The 108 gram means atomic mass of Ag is 108. So 108 divided by 108, that is 1 mole itself. Na atom. So which is equal to, we have to find out the number of atoms, has maximum number of atoms you have to find out. So Na divided by 108, which is equal to, what you will get? Something you will get. Okay, Na divided by 108. Now moving to magnesium, Na divided by 24. Moving to oxygen, Na divided by 16. Moving to lithium, Na divided by 7. So which one is having the highest value? Of course, lithium will have the highest value. So lithium has the maximum number of atoms. Lithium has the maximum number of atoms. Moving to the next question. In which case is the number of molecules of water is maximum? 18 ml of water, 0.18 gram of water, 0.00224 liter of water vapors at 1 atm and 273 Kelvin, 10 to the power minus 3 mole of water. So here mass of water, how will you find out the water? Mass is equal, you know that density is equal to mass per volume. Density is equal to mass per volume. So mass is equal to volume into density. So here 18 ml of water, you know that density of water is equal to 1. So mass of water here is 18 into 1 is equal to 18 gram. Molecules of water is equal to number of moles into Na, which is equal to 18 divided by 18 Na, that is equal to Na. Now here 0.18 gram of water, option B, 0.18 gram of water, that you will get 0.18 divided by 18 Na. That is equal to 10 to the power minus 2 Na. Then coming to option C, 0.00, it's given that 0.00224 liter divided by, you know, the 22.4 liter, that is equal to 10 to the power minus 4 Na. Then last one, it is given that option D, 10 to the power minus 3 mole of water, that is 10 to the power minus 3 Na. So which one is having, which one is having 1 Na here? So, in which case is the maximum number of molecule? Option A, 18 divided by 18. That will be the maximum number of molecules. Now moving to the question number 12. Suppose the element X and Y combine to form two compounds XY2 and X3Y2. When 0.1 mole of XY2 weighs 10 gram and 0.05 mole of X3Y2 weighs 9 gram, the atomic weights of X and Y, you have to find out the atomic weight of X and Y. Suppose the atomic weight of X is equal to weight of X is equal to small letter x, and the weight of Y is equal to small letter y. Okay, let it be. So for XY2, number of moles is equal to W divided by molecular mass. So it is given that number of moles is 0.1 mole. So 0.1 mole is equal to XY2 is 10 gram. Mass in gram is 10 gram. 10 gram divided by molecular weight. And for therefore molecular weight, how will you find out the molecular weight? You know that weight of X, you know, weight of Y, you know. So what will be the weight? X plus 2Y will be the molecular weight. So 0.1 mole is equal to 10 gram divided by X plus 2Y, that is this. Therefore, X plus 2Y is equal to 10 divided by 0.1, which is equal to 100. So what is X plus 2Y? X plus 2Y is equal to 100. Now we are moving to the next one, that is X3Y2. For X3Y2, it is given that number of moles is equal to mass in gram divided by 9 gram divided by X3Y2. That is 3X plus 2Y. And how many is the number of moles is given that 0.05 moles. So 0.05 mole is equal to 9 divided by 3x plus 2y. Therefore, 3x plus 2y is equal to 9 divided by 0.05. 9 divided by 5, 0.05. 9 divided by 0.05. So what you will get? 180. On solving equation 1 and 2, we are going to solve x plus 2y, 3x plus 2y. So x plus 2y is equal to 100, 3x plus 2y is equal to 180. So 3x plus 2y minus x plus 2y is equal to 180 minus 100. 2y minus 2y gets cancelled. 3x minus x is equal to 80. 2x is equal to 80, that is x is equal to 40. X is equal to 40, only one answer, that is option A. Okay, moving to the next question. If Avogadro number Na is changed from 6.022 into 10 to the power 23 mole raised to minus 1 to 6.022 into 10 to the power 20 mole raised to minus 1, this would change. What happens? The mass of 1 mole of carbon will change, The ratio of chemical species to each other in a balanced equation will change. The ratio of elements to each other in a compound will change. The definition of mass in units of gram will change. What is the change here? So you know that the mass of 1 mole of carbon is equal to mass of 1 mole of carbon is equal to mass of 1 mole of carbon is equal to 12 gram. Okay, 1 mole of carbon is equal to 12 gram. That is 12 gram contains 6.022 into 10 to the power 23. If Avogadro number is changed to 10 to the power 20, that is 6.022 into 10 to the power 20, if Avogadro number is changing, then what will we get? This will be 6.022 into 10 to the power 20 into 12 divided by 6.022 into 10 to the power 23. That is 12 into 10 to the power minus 3 gram you will get. That means the mass of 1 mole of carbon will get changed. Option A will be the right one. Here actually the mass of 1 mole of carbon is 12 gram, and if you that means it contains Na number, that is 6.022 into 10 to the power 23. If the Na gets changed to 6.022 into 10 to the power 20, then the 12 gram will changes to 12 into 10 to the power minus 3 gram. Clear? Very simple question. Now moving to the next question. The number of water molecule is maximum in. So water molecule, the number of water molecule you have to find out. You know that water, the mass in gram, number of moles is equal to, you have to find out number of moles is equal to mass in gram divided by gram molar mass. Number of moles N is equal to mass in gram divided by gram molar mass. So here the mass in gram, it is given that 1.8 divided by, you know, molar mass of water H2O 16 plus 2, which is equal to 18 gram. That is the molar mass. So here 1.8 gram means 1.8 divided by 18 into 6.022 into 10 to the power 23. That is equal to 1.8 divided by 18 is 10 to the power minus 1. That is 6.022 into 10 to the power 20 minus 10 to the power 22 will be the answer. Now 18 gram of matter means 6.022 into 10 to the power 23 itself. 18 moles of water means 18 into 6.022 into 10 to the power 23. 18 molecules of water means 18 molecules itself. So what will be the right answer? The right answer is the number of water molecule is maximum in option C, 18 moles of water. Is it clear, all of you? Okay. Now moving to the next slide. Next question, that is question number 15. The mixture of gases contain H2 and O2 gram. O2 gas in a ratio of 1:4, weight by weight. What is the molar ratio of the two gases in the mixture? The molar ratio you have to find out. So this is a cancelled question. Due to some reason it gets cancelled. So here, how to do this question? A mixture of gases contain H2 and O2 gas in the ratio 1:4. So the number of moles of H2 you can find out number of moles of H2. Ratio is 1:4. So 1 by 2. You know, total there are two gases. The number of moles of H2 is 1 by 2. And number of moles of O2 is 4 divided by 32. You know, mass in gram is 4. Gram molecular mass is 32. Okay. So molar ratio is equal to, what will be the molar ratio? Molar ratio is equal to 1 by 2 is to 4 by 32. 1 by 2 is to 4 by 32. I'm going to 32 here. 32 divided by 2, 16. Here 16 by 4 you will get. Okay. Now I'm going to divide it with a 4 both sides. So 4 is to 1. 4 is to 1 will be the answer. 4 is to 1. Yeah, here. Option D will be the answer. I don't know why they cancelled this question. This is how you can find out the molar ratio of two gases in a mixture. Okay guys, so far we discussed 15 questions. Hope you will like it and hope you will use this video for your upcoming preparation. Thank you all. Thanks. See you in the next video.